Good evening, students. Now we will move on to the next topic, that is non-parametric test. So far we dealt with problems of testing a hypothesis about a parameter. So they were called as parametric test. That is, we consider parameters like mu, sigma, etc. there. Okay. Now tests which do not deal with such parameters, they are called as non-parametric test. And so many tests like that are there, and one such test is called as chi-square test. Chi-square test. Okay, chi-square test. So this, now we will study what is this chi-square test. This is mainly used to find the goodness of fit, that is how far the attributes are related. That means suppose you need to find out, say, height of father and son. Is there any relation between height of father and height of son, or is there any relation between color of eyes of mother and color of eyes of daughter? So like that, attributes, when you want to study, we use their chi-square test, and we want to see which distribution, like among normal distribution, Poisson distribution, or any other such distribution, which type of distribution mainly fits into that given data. So for that purpose we use this chi-square test. So this is otherwise called as goodness of fit test also. Okay, and the statistic what we used, or the formula what we use to find this chi-square is given. It is written like x, but like this, chi-square. Okay, then it is given by summation of O minus E the whole square divided by E. That means, where here O is the observed frequency, E is the expected frequency. Means while we are collecting some data, we will have some frequency that is taken as observed frequency. Like that, for example, say number of accidents happening in a particular day. So we count that number of accidents, and that is the observed frequency. Using that observed frequency, we can calculate the expected frequency. So by taking the ratio of this ratio and summing up, you are getting chi-square. Okay. So here also, if chi-square calculated value is greater than chi-square table value, then again one more table is there to find the chi-square value. Then as always we reject this hypothesis, and if chi-square calculated value is less than chi-square table value, then it is accepted. Okay, here also we will find another table to find this table values. I'll explain that it later. And here here one important thing what we use is, when you want to write this H0, means null hypothesis, when we write here, always we take a negation statement. Like that, means there are so many types of this test. You have to test goodness of fit, that is one type, and second one is attributes, connection between the attributes. So here whenever you want to write this null hypothesis and alternate hypothesis, so always we suppose is there, you are asked to test whether there is any relation between height of father and son. So here we assume that there is no relation. Like this we will take, there is no relation between the height of father and son. Like that we will take, and alternate hypothesis obviously will be there is some relation between height of father and son. So these two types, that is, one is, this type is independence of attributes. In this independence of attribute types, we take this as the null hypothesis, and second one, in goodness of fit, we take the significant, means we write a positive statement here, and later we prove it or disprove it. Okay, we accept or reject that one. Then now in this one, this data which is there, this will be, say, given in some table like this. Means a table will be given giving the observed frequencies, and from this observed frequency we will calculate the expected frequency. Now suppose R rows are given like this, R rows and C columns are there. Okay, C columns and R rows are there. Say for example, now here 1, 2, 3 rows are there and 1, 2, 3, 4 columns are there. So total 3 into 4, 12 cells will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cells will be there. Okay, then from this only you can find the degrees of freedom. Degrees of freedom is given by R minus 1 into C minus 1. That is, if R is say 3 and C is say 4, then degrees of freedom means R minus 1, 3 minus 1, 2 into C minus 1 is 4 minus 1, that means 3. Okay, so 2 into 3 means this is 3 minus 1 and 4 minus 1. 3 minus 1 is 2, 4 minus 1 is 3, 3 into 2, 6 is the degrees of freedom. Now to calculate the table, or from the table we will get here, suppose I want to find chi-square say alpha at this 6 degrees of freedom. 6 degrees of freedom at L of S, level of significance say 5%. Okay, so in that case we will take this chi-square table. So I want to find chi-square alpha at 6 degrees of freedom at 5% LOS. So what you have to do is, like in a table, if 5% is given, here in this table you need to look for 0.05. If 1% LOS is given, then go for 0.10. Okay, so if 2% is given, then 0.02. So like that, whatever level of significance is given, that particular value on this top part you have to take here. And degrees of freedom, it is now 6. So here in this one, at the point 6, so here it is 6, corresponding value below 0.05. 0.05 and here 6. So it is 12.592. So chi-square alpha is 12.592. So this is the way to find the table value in chi-square distribution. Then here this observed frequency is given. Observed frequency is given. Suppose this is A1, A2 and here say total. This is total N. And here say B1, B2 is given. Okay, A1, A2 and B1, B2 is given, and here some observed frequency will be given. Then I can find the expected frequency here. So observed frequency, this is given. Expected frequency I will find using a formula. That is, what I will do here, expected frequency at this box, say E11. Expected frequency I will find that this is say O11 and expected frequency is given by this A1 into B1 means corresponding value O11 corresponding total A1. This is if it is total, this also if it is total. O11 is given here. I want to find expected frequency at this one. Then E11 is given by this A1 into this total B1 divided by total, complete total N. Okay, so if I want to, suppose O12 is given, then if I want to find expected frequency of 12, then it will be A1 into B2 divided by N. So like that, while solving the problem you will get it better. So that is the way to find the expected frequency. Now there are some conditions to use this chi-square test. The first condition is the number of observation should be sufficiently large. Sufficiently large means it would be better if n is greater than 50. Okay, so first condition to use chi-square test is number of observation should be sufficiently large. Second is that frequency of every cell must be greater than 10. That means if it is given here, if some values are given here, frequency of every cell should be greater than 10. If it is not 10, means if it is less than 10, what we do is we collect two consecutive values, means we take the neighboring value. Suppose some values are given like say 4, 8 or 4, 18, 12, 15 like this. So here this is less than 10. Okay, now this is 1, 2, 3, 4 values are there. So 4 values are there at present. Now since this is less than 10, what I will do is I will take these together. So 18 plus 4 is 22. 22, 12, 15. So what will be now number of values? Number of values will be only 3. Okay, this is one way of solving problem. And then if the cell value, if one of the values, if some values are less than 10, then we use a correction called as Yates correction, by ATES. Yates correction we use. So that is, if frequency of every cell must be greater than 10, if it is less than 10, then it is combined with the neighboring frequencies, so that combined frequency is greater than 10. Okay, and the degrees of freedom will be reduced accordingly. Then number of classes, means how many classes are there, that number of classes must not be too small or too large. The perfectly normally it should be between 4 and 16. Okay, so number of classes should be perfectly either it should be more than 4, it should be less than 16. This is a preferable class. That number of classes preferably it should be between 4 and 16. Okay, so this is the basic things about chi-square distribution. So mainly what you want to remember is the formula to find this chi-square, O minus E the whole square divided by E, summation of that one, that is chi-square test.